I'm the responsible director for the Field Level Communications Initiative as part of the OPC Foundation. And this initiative is responsible for developing the concepts and creating the specifications for the extensions to the OPC UA framework to meet the various use cases and requirements for the field level. Now, when we look at some of the key challenges for industrial automation in the context of digitalization and the digital transformation, I want to first of all mention that we still have a quite strict separation between information technology, IT, and operational technology, OT. But in order to support the use cases out of, for example, Industry 4.0 or the Industrial Internet of Things, we have to ensure a very easy and a very flexible information exchange across all these different levels inside a factory, inside a plant, or even beyond. And this is why we have to strive for solutions that support the IT-OT convergence. What we also recognize today is that we have quite different solutions, products, and even technologies that are being used in factory automation and in process automation. But the requirements are very similar, or I would say to a very large extent they are even identical. So it doesn't make sense to have here different solution approaches, but we have to come up with a harmonized approach which is beneficial to the suppliers as well as to the users. And one of the probably most difficult challenges to solve is the huge diversity with regard to protocols and data models, especially when we look at the field level, having all these different field buses and real-time Ethernet protocols, digital and analog interfaces. And if we look higher to the data models, having out of historical reasons the different data models with different data semantics, that make it really hard and really complex for those that want to analyze information out of the process, out of the production, in order to derive certain optimizations or to improve the overall efficiency of a production in a plant or in a factory. And this is where we urgently have to support also harmonization and to support the so-called semantic interoperability. Now, the OPC Foundation has launched about 2.5 years ago the Field Level Communications Initiative in order to extend OPC UA to also cover the field level. By extending to the field level, OPC Foundation is developing OPC UA as an industrial interoperability standard that is finally fully scaling from the field to the cloud, vertically in both directions as well as also horizontally, allowing a very easy and a very flexible connectivity between devices, between controllers and devices, and even with all the different software applications, independent whether it's in the field, in the edge, or in the cloud. OPC UA today is used in many different use cases. You see here some of the examples, numbers 1 to 4. So secure remote access, local OT communication, and also cloud integration. With the Field Level Communications Initiative, the use cases are extended to cover also the controller-to-controller use case, the number 5, and the controller-to-device use case number 6, including also device-to-device. And the extensions that are being developed by this FLC initiative are then supporting additional features and functions, for example, functional safety, real-time data exchange, including deterministic transport, but also the various applications and device types in automation, for example, motion control, remote IOs, field instruments, and so on. And the name for these extensions is OPC UA FX, FX standing for Field Exchange. A few words about the Field Level Communications Initiative itself. This initiative is part of the OPC Foundation. We have overall 27 member companies that built the so-called steering committee of the initiative. If you browse through the logos, you find all the big names in industrial automation. Out of the US, the companies Emerson, Rockwell Automation. Out of Europe, the big names ABB, Schneider Electric, Siemens. And if we look to Asia, we have the big automation suppliers out of Japan with Mitsubishi, Omron, and Yokogawa. Overall, more than 320 technical experts from more than 65 member companies of the OPC Foundation are supporting the technical work to build the specifications for extending OPC UA to the field. So we are really proud to have this tremendous support from all these companies all around the world. Now, first of all, I want to highlight that in order to support industrial interoperability, you need to have standardization at all the levels that are listed here on the slide. So you need standardized network access, you need standardized protocol, and you need standardized data semantics. The solution for field exchange, OPC UA FX, is built upon existing OPC UA technology with the built-in security, with the information modeling, with the client-server services and the publish-subscribe extensions. The technical working groups of the FLC initiative are then extending the information models to support the various automation components, including offline configuration and including common behaviors, for example, to set up connections between the various automation components and to do the bootstrapping of a complete system. On top, we then have the various extensions and features to support the various application areas and the various device types. So there are facets for functional safety, for motion control, for instruments, for IOs, and so on. And the concepts are done in a way that existing device companion specifications can be integrated. So this is where we can, for example, integrate the PADIM information model or the MDIS or the DEXP and all the other companion specifications that are elaborated through the numerous corporations the OPC Foundation has all over the world. Now, if we look at the lower levels, we are relying on various IEC and IEEE standards. Very important for us are especially the Ethernet standards out of IEEE, with the certain variants, for example, the Ethernet Advanced Physical Layer APL that is being launched in these days at the ACHEMA. Very important to bring Ethernet to the field in the process industry, but also Ethernet TSN to make transport deterministic is very important, as well as other communication standards that are being developed by standardization organizations. We are defining two communication profiles to map the information models on the higher layers to the underlying network and transport protocols. So we are supporting a UDP/IP protocol for a routable, flexible protocol, as well as supporting a so-called direct layer 2 mapping when it comes to a more efficient or highly efficient communication, for example, inside a machine for distributed IOs or high-speed motion control. The concept is also created in a way that we can easily adapt to other upcoming communication standards and technologies. Important to mention is especially 5G. We have established a cooperation with the 5G ACIA to support 5G inside the OPC framework to also support wireless communication. And in future, we will also extend to other wireless standards such as Wi-Fi 6, Wi-Fi 7. Finally, I want to highlight that we work on conformance tests for the various automation components in order to ensure high compatibility and a high level of interoperability across the various vendors. A key technology for OPC UA in the process industry is the advanced physical layer Ethernet APL, as already mentioned, because this is bringing Ethernet to the field even in hazardous areas. And because APL is transport agnostic, it is supporting different industrial protocols, including OPC UA. And this is why the OPC Foundation has become member of the APL initiative a few months ago to support the further development of the technology and also to jointly promote Ethernet APL with other standardization organizations. Another key enabling technology is Ethernet time-sensitive networking, TSN. This is important out of two reasons. First of all, TSN is supporting deterministic communication with standard Ethernet. So this is absolutely essential to cover the various requirements for real-time data exchange in the various applications in automation. But there is a second very important aspect, and this is that TSN is supporting so-called converged networks. These are networks where different IT and OT protocols can coexist, which is a key element in driving that IT-OT convergence that I mentioned before as one of the key challenges to support Industry 4.0 and the industrial Internet of Things. Because of the importance of TSN, the OPC Foundation is aligning with the IEC IEEE 6802 activity, which is defining a TSN profile for industrial automation to make sure that there are not different flavors of TSN, but we are supporting a commonly accepted network infrastructure that is also supported by other OT protocols and the IT stakeholders. Now, talking a little bit about the current status of the project and the achieved results. The first specification release, the so-called Release Candidate 1, has been completed, consisting of 4 parts, parts 80 to 83. And these specifications are currently being used to do prototyping and to create test specifications as well as test scripts for the certification tool of the OPC Foundation. And furthermore, these specifications are laying the foundation to do specification enhancements for the additional use cases, controller to device C2D, including also device to device D2D in the next step. What I already can announce today is that we are currently preparing a controller-to-controller interoperability demo based on this RC1 specification release. The demo is planned for end of November at the SPS Automation Show in Germany. And we expect more than 15 vendors and more than 20 prototypes to be included in this controller-to-controller demonstration system, showing the exchange of process data, real-time data, even safety data between controllers of different manufacturers. Now, as you have already seen, functional safety is a key element of extending the use case of OPC UA to cover also controller to controller and controller to device. This is why I want to give you a quick update on all the activities around OPC UA safety. For some time, we already had available a published specification OPC UA Part 15, Release 1.04, covering client-server mechanisms for controller to controller. In the meantime, an updated specification has been completed and in the meantime submitted for member review. This is OPC UA Part 15 Release 1.05, which is now also supporting the publish subscribe extensions. So this matches the OPC UA FX requirements. In future, we can expect further enhancements to support also the controller to device use case. A test specification has already been completed for OPC UA safety, and we have different ongoing developments on a test tool on the one hand side, but also on a safety stack. For this, OPC Foundation has contracted the Institute IFAG in Magdeburg, Germany, co-funded by 31 OPC Foundation member companies. And if there is interest from additional companies to join these development projects, please let me know. Now, with this slide, I want to explain a little bit the migration path with OPC UA from existing systems to support in future also OPC UA in the field level. You see here the classical solution, having controllers that use OPC UA to connect up to the edge, to the cloud, to the MES ERP systems. And we have the field buses that connect the controllers to the various underlying field devices. Now, with the controller-to-controller specifications developed by the FLC initiative, we allow the horizontal integration and horizontal communication between controllers of different manufacturers. So this is the initial step. And then by bringing OPC UA down to the field devices with the use cases controller to device and device to device, we then have OPC UA as one consistent and one standardized interoperability communication solution that is fully scaling vertically as well as horizontally. Now with this slide, I want to quickly summarize the content of my presentation. I wanted to show to you how the OPC Foundation with its field level communications initiative is extending OPC UA to support also the field level. And with this approach, there is the possibility to finally convert the traditional automation pyramid to a very universal, to a very flexible information network where we can have direct connections between the various field devices, controllers, different software applications, independent whether they are located in the field, in the edge, or in the cloud. And the solution is to extend OPC UA to meet the various use cases and requirements in factory and process automation with the support of different underlying technologies and standards such as the Ethernet Advanced Physical Layer, Ethernet TSN, 5G, and in future also Wi-Fi 6, Wi-Fi 7, and whatever comes up. I'm now coming to the end of my presentation. I want to thank you all for your attention. In case of any questions, feel free to contact me. You have here my contact details, but you can certainly also look at the various links that I'm providing here to identify related material. We have brochures, we have recordings, we have slides available. So please have a look, and thank you very much again.